people available for your production. That war of talent is a topic for a lot of our customers. And it's also available on a global base, which is often in line with the fact that you can achieve lower latency everywhere around the globe. And not to forget about the billing, the costing. We see a lot of customers, they look after more activity-based costing to really charge per utilization. When you use infrastructure for a production, then you only charge your customer for that, and you don't charge for building infrastructure or for building a studio. But when there's so many good things going to the cloud, why is it not just happening for everybody? There are challenges coming with it. And cloud migration, as we say, as we see it in Skyline Communications, is not just another technology project. Andy mentioned that as well before in his presentation. It's not just the move from analog to digital or HD to UHD. It's a different topic. What we say is part of a digital transformation journey or project. And what is digital transformation? There are many definitions out there. The one I like most is the definition to say you need to be capable to deal with change easily and efficiently. And that involves changes not only in technology, that's what we often tend to focus only on, but also on people and methodologies. Methodologies is mostly about building an agile operation, moving away from that traditional waterfall method, how to deploy projects, where you planned, installed, and then you were operating for a couple of years without too many changes involved. You want to go more into that DevOps style of operations, CI, CD, CO for operation, where you create in an agile manner, in a more software-driven organization way, where you operate and where you evolve over time in small, small steps and not just in one big step every couple of years. When we look into a live production, there is always a life cycle to it. It's not so much different compared to on-prem productions or traditional productions, but it's probably more complex. We have the fact in the cloud you need to deploy infrastructure, what's called infrastructure as code, and you have all those phases. When you look into the whole life cycle of a production, you need to plan. Then you need to deploy. You need to deploy infrastructure before you can use it. You need to configure it, apply the right configuration, templates to it. Then you run it, monitoring control, and then not to forget about deconstructing. It's not only about turning the lights off in the studio, you really need to deconstruct to save money and not to run instances in the cloud that you don't use anymore. And when you look into who is involved in that life cycle, there are different teams involved at different steps of the life cycle. You have the planning team, you have the MCR team probably, you have the production team, and you have other teams being involved and contributing to such production. When you look into the administrative data, like event name, job name, start, stop date, what kind of resources do you want to need, what type of production do you run, that often gets gradually collected. You have one team, the planning, the scheduling team, starting very high level, adding probably just a start, a stop time, giving it a high-level grid of what you want to do when, in which studio. And then you have other teams gradually contributing more and more data over time before you run or before you can run the production. And those transitions between those steps, they also need to be managed. You need toolings or a software that helps you managing those transitions. Usually today we see that a lot, it's done via Excel sheets or any kind of emails, but not really managed in a good way. Then you also need to orchestrate or manage the resources. And resources are not only cloud resources, you still have some on-prem equipment, and you also have what we call virtual resources. That can be studios, can be people, everything you also need to run a production. And that whole life cycle, as we say, has a combination of manual and automated steps. A manual step can be an approval process. You cannot just say, I book a studio or I book certain resources and you run it. There is often somebody involved who needs to approve it. That's an extra step, an extra process you need to consider. Then you have those automated steps, because it's everything about, at the end, automation when you run things efficiently, when you want to run things efficiently. That can be, for example, the fact that you need to reserve certain resources on-prem or in the cloud. And also you need to support what we call linear and non-linear steps. A linear step for us is the production itself. It has usually a pretty much defined start date, stop date, where you need a certain set of resources for a certain amount of time. And then you have those non-linear steps. That can be an approval process, as an example. An approval process can be something very simple. one guy hits a button that takes a minute, but can often in reality also take a couple of days or weeks because things are not ready yet. Approval gets stuck, it's pending, gets rejected. That's for us a non-linear process, but you need to consider the fact that it's not having a defined start and stop time, and you don't know how long things take. And then, last but not least here, you need to support productions that vary and evolve over time. In the past, when you look into on-prem studio productions, that's much about reconfiguring equipment. Now in the cloud, we talk about redeploying infrastructure as code again, to do different things with your infrastructure. So many things to consider, a few pitfalls. The one on top, and I don't go through all the list here, we see more and more, there is no guarantee. Remember that when you go to one of the public cloud providers that you have the cloud resources always available. Especially when you talk about big instances and GPU accelerated instances in special regions, you try to spin one up, it's not there. What are you doing? You need to consider that, you need to plan a bit in a different way. Also what we see and what we learn from our customers when we do some exercises on costing, it's often simply the fact that people forget or are lazy or are stressed out after production and they forget to turn instances off. That happens on a Saturday evening, they pay for another 48 hours until their manager comes back Monday morning, and they paid for another 20 instances for nothing. We did the same during IBC, by the way. It happened to us as well when we left IBC. We went for a beer, but we forgot to turn our own booth down. APIs are complex. They're constantly changing. This is much more complex than traditional APIs from some appliances you're used to work with. There's nothing like SNMP anymore. You have proprietary standards, that doesn't go away. One example, CDI, great tool, works in AWS, but there's nothing like a CDI in other cloud providers. The risk of vendor lock-in is still there, even in the cloud, maybe even a bit more than before. Think about that. Then, a lot of cloud management tools, they don't have support for on-prem equipment. What are you doing with that? And what I also want to mention is that lack of confidence. When you run things in a very dynamic way, you need to build that trust with your operations. How do you know when it's not there at the time when you book it that it really will work? You need some tooling as well to do what we call spot checks, to do constant automated checks when you spin things up that it's really working. You cannot just trust the whole equipment. And doing those checks manually doesn't work because nobody has the time. So there's again automation involved just to make sure what you build will actually run when you need it. What we did there, this was a demonstrator, what we call a sample application. We have done an integration with Grass Valley AMP, this ecosystem for live productions, together with an intercom solution from a company called RTS. They built virtualized intercom panels. And we were showing an end-to-end workflow at the Grass Valley booth to our customers that included resource orchestration, really from drafting the admin data, gathering admin data, including full automation, spinning up and down all the resources, monitoring things, and then also reporting costs and doing cost prediction. And the way it was built, I can't go through all the details here. It's also built on a CI/CD platform internally at Skyline Communications. We are using Jenkins. Our customers are mostly on GitHub. We help them building up that CI/CD platform to set up such workflow. Two things I want to focus on today is what we call object modeling and service templates. And what is that? Object modeling is a way to gather administrative data. You need to define a data model, something pretty simple. It looks like it's simple at first stage. You have mandatory fields, you have optional fields, can be a job name, an event name, you give it a start, a stop time. You have some optional fields just to gather data. We don't do much, but we want to display data, like the contract, the venue. Nothing we really need to orchestrate, but you want to have one single place where you have all the administrative data available. Very important on those model definitions, we need to link that administrative data to a production type. There is a list of predefined service templates, and I will explain in another slide what a service template is. Once you enter data or add data, we call it an instance. That's how things work in data modeling. And that's really the basis to do something with that admin data. You have that production type, the list of service templates. We create instances. And so far, so good. You might think that's what I do in Excel. True. But an important aspect is the fact that those objects, they need to be state aware, as we say, because you have different states to support that full life cycle. And here's a very simple example. You might have a draft state. Somebody starts entering a bit of data. There might be a state to wait for an approval. So a human needs to hit an approve button. Then it's unconfirmed, because automation underneath was about to successfully reserve the resources. Then it's in running. That's where the actual production runs. But you see there's a lot of things you need to do before. And then it's completed. And it's always a mix of automation underneath plus users doing certain things, like approve or reject. It's a user. You cannot automate that. Automation is maybe something like reserving resources or running an approval process. And that's really important, after each transition from one state to another, the way we built it, you can run any kind of automation, something very simple or something super complex, and I will show you a few examples in there. But being state aware is key also for our customers, and that explains a lot why something simple and like an Excel sheet doesn't really work anymore, because you can't do anything like versioning or things like that to manage the administrative data across different states. And then we need service templates. We need some resources at the end we want to orchestrate and bring up. Service templates are used to manage the resources. And the way we do it, you specify building blocks. You have a canvas where you define the type of resource you want. Here, very simplified again. On-prem, we had a couple of JPEG XS converters. Then we need a few players. I need a multi-viewer, video mixer, an output. I also need people. Those are resources. And everybody needs a panel, an intercom panel. So you specify the functions, how things will be connected, and some dependencies. But you do not specify anything around the vendor or the APIs yet. So you build that service template fully independent of any underlying infrastructure. Why are we doing that? You want to be flexible. You want to reuse your service template even in case you have to move to some other infrastructure or use infrastructure from different vendors. Where are those resources hosted? There were on-prem resources, my converters. Then we had the GVM system running in the private cloud from Grass Valley, somewhere in Canada. We have virtual resources, our operators. And then we had public cloud resources. They were running on an AWS EC2 instance. Those were the intercom panels from RTS. Now, how to link those function blocks, those building blocks, to resources, that's something we need to do. There is a linking mechanism. As a second step, once you have found, let's say, 3 players, GVM players, applications to fulfill the need for 3 players here, you need to apply what we call profiles, which is a set of parameters to each player to configure a player, let's say in SD or HD or UHD, load the right clip IDs. And then we need to translate as a third step those profile parameters, because you define them again independent of the vendor, into vendor-specific API calls. We call that a mediation layer. With that, we kind of decouple the operations from the underlying infrastructure. Once more, when we would ever change from one vendor to another, or there is one vendor disappearing, or there is a new product coming out, you don't have to change anything on the operational level. You just replace things on that mediation layer. Gives you the possibility to follow those CI/CD principles to constantly run and do changes ad hoc. Let's have a bit of a closer look into those profiles and resources. Profiles, again, pretty simplified here. A JPEG XS converter, you might want to change or set the bitrate, the format, the JPEG XS profile, a sender IP, which comes from a pool of multicast addresses managed by the orchestration system itself. Players can be the clip ID, the format, intercom panel. Interesting here, it's the operator. It's the operator's name, because you want to have the operator's name showing up on the button of the intercom panel, not just something like operator 123. There's a good reason why we also manage people and do some rostering. How do you do that on the resources then? How do you map profiles to resources? We work with resource pools. Resource pools can be from different vendors, and every resource, that's how we defined it, has 3 key metrics. That's availability, capacity, and capabilities. Availability can be things like it's free, it's reserved. It's in plant maintenance, means it's reserved, but not by production, but by another team, or it's in error, then you can decide what to do. You might still want to use it. It's not a critical error, or you can't use it. Capacity can be many things, but often it's network, bandwidth, also software licenses, mechanisms. There are examples out there when you have a 100 gig connection, but your decoder or receiver is only licensed for 10 or 40 gig. An orchestrator needs to consider that and take it into consideration when you assign some resources. Then capabilities is often technical capabilities, but also locations. When you have a resource pool of 50 JPEG XS converters in different stadiums, you have to store and save that information somewhere. We do that in capabilities. And then we have something on top, what we call data transfer rules. That allows us to inherit profile settings from one to another resource. The way we deploy and configure infrastructure is not just all together. It's often in a certain sequence. You have a sender first. You assign a multicast address from an IP address pool. And once that's done, then you can only set the receiver IPs on maybe a recorder or the vision mixer itself. So there are always dependencies when you configure things. That's what we use data transfer rules for. How do we actually deploy then? Infrastructure is not that you can just run infrastructure. On-prem, it was often infrastructure was running 24/7. In the software-based world or cloud resources, you need to have a bit of a different approach because there are, again, dependencies, what we call the north-south stack. The resources, that's important to remember, they usually don't exist at the time when you book them or when you make a reservation. You want to have some resources, but they don't even exist. And to make them available, there's different things you need to do. On our JPEG XS converter, just one example here. What did we have to do? This was a Lavo example. There is a Lavo vMatrix system. It has some C100 boards in there. Those are FPGAs. And then you have to load the actual media application. Because one day it could be an H.264 encoder, but we need a JPEG XS converter. So you need to reapply an FPGA or reapply the firmware. On the Grass Valley AMP ecosystem, you have to spin up certain virtual machines. On the intercom panel, you have to spin up an EC2 instance first. Otherwise, there is no way that you can configure and have access to some of those intercom panels. So first, you need to deploy what we call the contributing resource. Once that is up and running, then you can configure the actual production resource. Going back to our original slide here, you have those different states. We do different things. At the end, when it's completed, we free up resources again. Looks pretty straightforward, but it's not always like that, because when you look into that north-south stack, you have, again, dependencies with other productions. When you spin up an EC2 instance on that RTS intercom system, they had a license for 20 intercom panels. We use 3 for production 8, 17 left. You cannot just spin down the EC2 instance when your first production is done. You have to consider that maybe another production is still using some of those intercom panels. So there are dependencies. And more important, those states, as they are shown here, they're not always straightforward. An approval process is not just a button. It's something like that. It's a business process. There are different states, again, within the approval process. We need to automate as well. You receive data, can be completed. You might have to edit some data. You might validate data. You can reject it. What are you doing then? You cannot just say, here, it's over with the automation. Good luck. You need to manage those situations until it's approved. And only when things are approved, then we can start reserving those resources. Same thing on the resource management. When you go from the fact that you can have a resource reservation until you spin down and turn off and free up the resources again, you have, again, different states. We call them production states. Can be confirmed, easy, but a production can be canceled. Bad weather, production doesn't happen. Can be in a partial state, not every resource is available. Can be in quarantine. That happens when resources all of a sudden are not available anymore. Things go wrong, or an on-prem resource dies. You need to do something. Find another resource, maybe apply a different profile in case you don't have enough capacity. You better do an SD encoding when there is no more capacity left for an HD encoding, or you have to reschedule. That's the other alternative. And also the service state. here is not only that you have a simple running state, you often have a standby state when you spin up the instances. It takes a few minutes to spin up an EC2 instance to run the media application before you can use it. There might be a pause state and so forth. So overall, it's much more complex than it looks like, but an orchestration system needs to handle all those usual situations, but also the unusual situations and the exceptions. And once everything is done here, then you still need to operate it, and that's the third one I want to talk about. There we use so-called low-code applications. What are those? Applications our customers can build on their own, as the name says already a bit. We call them low-code apps because you don't have to be a hardcore developer. When we talk CI/CD, a lot of people think it's only for developers, which is true. A lot of developers use it since many years, but it's more and more where we say we democratize coding, and that's done with low-code applications. I'm not a coding guy at all, but I can still build some of those because you don't have to know anything about C#, etc. And that allows you to build the monitoring and control front ends tailored to specific needs. And that's often same data displayed in a different way for different people because they have different needs. And you need to have a way to build and evolve those user interfaces over time. Very important at runtime. When you want to do small changes, small iterations in an agile world, you have to have a system or a tooling that allows you to do those changes at runtime. Otherwise, you will never do them, because then you would be blocked. Just a few screenshots here. We say it's always the right interface for each team. This was a very simple user interface to enter administrative data. HTML UI, the way you build them here in draft state is in a way that you guide people. You have mandatory, you have optional feeds. There's nothing you can really do wrong as an admin guy, and only if you have entered all the mandatory information, like my start, my stop time, the production type, then you can put it to the next step and hand over to a different team. It's a guided workflow. Important here, not everything is always fully automated, because automation sometimes is complex to automate things that don't happen too often. It's not worth automating, but still you should focus on a guided workflow. It helps people already a lot when you just tell them on a system what an operator or a person has to do next. Instead of fully automating, you can just give indications, and when the person has done certain things, he hits the next button saying, I've done my job, and you move on. There's always a mix of automating and manual steps, but in fact, manual steps in a way that is very guided, that you have a certain workflow people need to follow. And here's another screenshot. It's more for the operational people or people in the planning after somebody has entered the first initial data set. Simple things like a scheduling view. You see the different states again, if it's ongoing, confirmed, or in draft mode, or maybe it's done already. You see some states, and this is just a demonstrator in a very simplified way, about the EC2 instance. If it's up and running, some states about the Grass Valley AMP applications, if it's running, ready, or in stopping in that case. So that schedule overview, the resource states, everything together for certain people to manage that production lifecycle, to have buttons to say, I want to expand my schedule because it's overrunning, or it stops early, then I stop and shut down my instances again. Very important. What we underestimated a bit as well, you need to provide dynamic links, because for operations, the guys operating, how would they know how they can access the right user interface? It's all dynamic. So far, people often send emails and said, here's the URL for your Vision Mixer UI, for your intercom panel, but that can also be automated instead of just calling people and sending around URLs. Build dynamic links, and then people can access the user interface. But this is my third team, the operational team for the production. And we always say, in case there is already a user interface that does the job, this is the Grass Valley Vision Mixer UI, just use that one. There is no need to reinvent the wheel. In this case, we have embedded the UI on that application, but you can also load the user interface standalone, like this one here. I just did a quick screenshot from the RTS panel. And you see this is the name of my colleague showing up for that production, because I have reserved Helber in that case, and another party line that he gets his virtual intercom panel. Or in case there is no user interface available that does the job, you can build your own UI, and there was a very simple one here. where we just allowed people to select different clips, to do some playout control and select different layouts on a multi-viewer. And how do you, oops, wrong button. How do you then evolve? I don't show much details about the data modeling and the user interfaces there on the service templates. That's a screenshot from the edit mode when you want to edit some of the operational user interfaces. And all I want to basically say is there is no coding required. You see, it's pretty much a drag and drop user interface. There is no hardcore coding. You can add and remove data. Once you get familiar with that, and that's typically something you can learn in a few days realistically, you are able to evolve your own user interfaces, the data you want to access, and publish a new version that's important at runtime. All you do your changes on the fly, ad hoc. If you have the admin rights, you publish a new version. And then most important, that version goes online. Everybody can use it immediately. And you always have the possibility to look into your version history and to also roll back. Don't underestimate that. Rolling back happens because things still go wrong when you think you have done the job right. Your colleagues might complain they don't like the UI you have just published. You need to roll back. And rolling back is sometimes, or being capable to roll back is sometimes more important than publishing a new version in a very easy and simple way for our customers. As a summary, and that's not only like true for live productions. Live productions here are an example because they're complex when you run it in the cloud. But treat those projects not as waterfall project anymore as you have done it before. And cloud projects are good examples. They need to be handled as a digital transformation project, as we say. And there's the three main components to us. This is technology. It's not only that you invest in new IP technology, you also need the right tooling to glue those things together, to automate as much as you can, or if you don't automate, to give at least guidance to the operators, to the users, what to do next. Then don't underestimate the efforts on the people. You need probably different people, but moreover, you need to educate people and also what we call empowering people. Give them, again, the right tools that allows them, without being hardcore coding, people to evolve over time and to do small iterations, do small things. And then about methodology, that's more of a company effort. You really need to live the fact that people need to work much more agile. Instead of doing big definitions on papers and 200 pages of a Word document, follow agile. We use Scrum within our company. A lot of customers are following as well, where you have like bi-weekly sprints, you do small iterations, and you want to produce value fast. Because when you look into such projects, it's not something you do and deliver in 3 months and you never touch it. There's always new ideas, there's new things are changing, and you need to be able, again, to react fast and to adapt to change, because you can't really foresee what's next, what happens in the next maybe month or years. That's completely impossible, and that's what really the key is of digital transformation, to be able to react to changes or to new conditions. And with that, I guess I'm still pretty much in time. Thank you very much.
All right, thank you.